Hello, class. In this video, I just wanted to take a few moments to explain your project. So if you click on the modules section of Canvas and we scroll down to the Unit 2 project, oops, that's Unit 3, and here we go, Unit 2. Here's our checklist. So I put the project in two types of formats. I did it in Word and PDF. Sometimes the symbols don't come out correctly in Word, depending upon the computer you're using. So I also attached it as a PDF. So if I open up the Word document, I click on it. It's going to load here and give me a screen, but I actually want you to download the Word file because I want you to type your projects. So by opening up a Word document, you can type your answers directly into the Word file. Okay, so I'm going to click on the hyperlink here, download project 2, and on my computer it actually downloads the file to the bottom left of my screen, and then I can just open up the file. Some of your computers, it might download to a different location. So I will open that file up now. And here is your project. You'll notice the project's really just answering a total of, say, 12 questions, okay? So my suggestion would be really just type your answers directly into the project. So you look at the problem, right? We have two job offers. Job 1 has a starting salary of $33,100, and you get a raise of $1,050 each year. The other salary, the other job, you start out at $31,500, and your raise is 3.9% annually. All right. So I guess what we're trying to get you to realize here is one of these tables is a linear function, and one would be an exponential function. And I would think the salary that grows by some percent will be your exponential function, and the salary that has a fixed dollar amount would be your linear function, right? The fixed dollar amount would be your slope, okay? So let me just write out those two equations for a moment. So I just wanted to remind you, right? A linear function, we have y equals mx plus b, where m is our slope and b is the vertical intercept or y-intercept, or b is your initial value. So in this case, the b would be our starting salary, right? Our initial salary is our b, and the slope would be your raise, which is, I think, $1,050. And for the exponential function, if b is greater than 1, that's our growth factor. If b is between 0 and 1, that's our decay factor. And now the a is our initial salary, right? So when we have to write our equations, the initial salary or the beginning salary is your a. And then the b is your growth or decay factor. And now remember, the project gives you this 3.9%. That's not b, right? The percent is not your growth or decay factor. They give you the r, the rate. Right, so you remember you have to convert this 3.9% into B, and there was a formula for that. Right, you remember for growth, B equals 1 plus R, and for decay, B equals 1 minus R. So if we're talking about a job and a raise where your pay goes up every year, I would think you would use the growth formula. So you're given the R, you have to identify the B to sub into your equation, okay? So getting back to your project, right, your initial salary for job 1 looks like you start out at $33,100. And your initial salary for job 2 is $31,500. And job 1 has a $1,050 raise, so I would add $1,050 to this number, and it should increase by that same amount every year, where the $31,500 is going to grow by 3.9%. So figure out, if you start out at $31,500 and then you earn a raise of 3.9%, well, how much is that raise? And then add that to this number. And then be sure that you pay attention here. It says round to the nearest dollar. Okay, so that's important, okay? And then also be mindful of this. For the successive ratios, you have to round 3 decimal places. So make sure you follow the directions here, okay? And so that's how you start to fill in this table, okay? The successive differences, if you're going to fill in this row, I would subtract whatever's in year 6 minus whatever's in year 5 and put it in this box here. Let's see if I can highlight that. And here, right? So I would do the 6 minus 5 and put my answer here. Then I would do the 5 minus 4 and put my answer here. I'll use a different color, okay? And so on. So you can almost work backwards, right? So difference means subtraction. So whatever the salary is here in year 6, subtract that from the salary, or subtract year 5 salary from year 6 and put your answer here, right? 4 from 5, put your answer here, subtraction. Ratio means division, so you would take your year 6 salary and divide it by year 5 and put your answer here. Year 5 divided by year 4, put your answer here, and so on, okay? And then you're going to do the same for table 2. And then just note, one of these tables, all of your differences will be the same. One of these tables, all of your ratios will be the same. If your successive differences are the same, well, that's the test for a linear function, so you know that table will be linear, meaning you'll have the y equals mx plus b as your formula. And then one of these tables, all the ratios will be exactly the same. That's how you know the table is exponential. And you'll have an exponential type function, again, that will be in this form, y equals ab to the x for exponential, and y equals mx plus b for the linear, okay? Now that we have that done, so for question 2, you're just going to literally just type your answer, right into the document. Oops, apparently I had trouble with formatting. So which table the difference is constant, and you can just put table, and I'm not going to tell you the answer, so I'll just put table question mark would be my answer there. What is the constant difference? Again, I won't give you the answer, but I'll just say, the difference is 1,000, some big number. It's really not going to be that big, actually. But you're going to put that answer, whatever your answer is, you're going to put that in here, and then keep going. And then you'll notice when it says write the function rule, right? So that's either going to be something in the form of y equals mx plus b or y equals ab to the x. But instead of using y, they use the letter s, okay? And instead of using x, they use the letter t. So if you thought this was linear, you might say s equals mt plus b, right? That's the same as y equals mx plus b. Again, they just used s for y and t for x. And if you thought it was exponential, you might say s equals ab raised to the t, right? A times b raised to the t, and so on. Let's see if I can make that a little bit bigger. Okay, and again, you're just going to go through all the questions one by one and answer them, and that will basically be your lab. One of the other problems on this lab that seems to cause students trouble, how to fill in this table, table 3, cumulative earnings, right? That just means if you worked 1 year, if your initial salary was $31,000 or $33,000, well, after 1 year, your cumulative earnings would be just the $33,000, okay? Now, if the next year you earned, say, $33,000 plus the $1,000 raise, right? So call it $34,150. You would add these two numbers together, right? 33 plus 34 is 67. And notice you have 67,250 here. And then to get year 3, you would add these 3 salaries, right? So 1, 2, 3 years worth of salary, and that would be your answer for year 3, okay? And then you're going to do the same thing with the second table, and then eventually you're going to subtract these answers to get the third column, okay? I also want to point out, when you look at question 9a, it looks like there are 3 points here, but this is really x is 2, and y is 35,200, right? There's not 3 points here. I know with the extra commas it looks tricky, but it's really just 2 points, right? Or 2 coordinates, right? X is 2, y is 35,200. X is 2, y is 67,250, and so on. Okay? All right, hopefully that helps. I will collect the project at the end of the semester. Thanks for watching.